Okay, so please, you just have to bear with me. My camera is upside down. I guess I have to just work with it like this. So you're welcome to the bootcamp, machine learning bootcamp, and I sincerely want to appreciate every one of us that has come, and I believe that we are going to learn something by the end of this lesson, or by the end of this time. So, Daniel, you were asking a question.
Yes, I studied the anaconda just not too long from now, and I'm trying to look at for it on my system. I can't find it. I don't know where to look for it.
Okay, you were trying to look for it. Okay, can you go to your search button, as in search bar?
Yes, I'm doing that.
Okay,
Please,
search for Jupyter Notebook.
search for what?
For Jupyter Notebook.
Okay. Yeah, I've seen some things on Jupyter Notebook. I saw Jupyter.exe app.
Okay, you are going to see Jupyter Notebook itself. Just just click on it. Have you done that?
What I found is that Jupyter.exe and also Jupyter Lab. You know, yes.
Okay, instead of that, um, search for Anaconda prompt. Just type Anaconda. You are going to see Anaconda Navigator if you installed it correctly.
Yeah, it's anaconda navigator, but it's like searching the web, so maybe there's like
Oh, I don't know. I don't know, Dan. Please, we have just an hour to do this, so please,
it's fine, it's fine, it's fine. Yeah.
yes, yes, so we are all welcome, and I hope we have all gotten the data set.
Yes.
Okay, okay. Um, it's all right. So I'm going to share my screen right now. The I'm going to share my screen so that we'll see. Okay, can you all see it?
Yes.
Okay, it's all right. So we are starting out. Now, I will open my Jupyter notebook. Already, it has been opened. If you see, okay, it has not been opened. Now, what I usually do, please just watch my screen. I will come to the search bar this way. Then I'll type Jupyter notebook. Okay, can you see it? So the Jupyter notebook is already showing the app. So you simply click on it. So I'll be turning off my camera now so that I can fully concentrate on the presentation. I'm afraid it is not. Yeah. Okay, so can you see that there is a good? So um, this is the home page of the Jupyter Notebook. Now, what I'll simply do, I'll go to the I will locate the folder that I want to use for this particular project. So let's assume I want to use the document folder. I'll simply come to the document folder and then I'll click on new. So I need to create a new Python 3. I'll click on it. So first of all, when we see the data is in the format of a zip file. So and you know what a zip file is. A zip file is actually a kind of a compressed file. So in order for you to access the data set from the zip file, you have to use a computer program to unzip it. That is the normal way. But part of this project, I'll be showing you how to open a zip file even in, that is directly from the Jupyter Notebook. So that should in case, maybe as a data analyst or data scientist, you don't have a computer program to unzip it, you can directly do that using the Jupyter Notebook. Now we are in a new Python 3 and first of all we want to import necessary libraries. So we are importing okay. Now the first library that we are going to be using is what we call pandas. Now we import pandas as PD. And then also the next one I want to import is what we call the zip file. I hope we've installed the zip file. Hello, can you hear me? Rachel. Hey Ben. Yes, I said I hope you installed the zip file.
I just came on now. I wasn't seeing it. I just saw it now. I'll
Oh,
try and get it from Mr. Daniel.
it's
Mr. Daniel. I just have to.
it,
I don't have them now. That's just
it's all right. It's all right. So, um, what of you, Rachel? Oh, it's all right. So now we want to import bytes IO. Now, the zip file is actually a Python library that enables us to read zip files. It helps us to open it up so that we don't have a challenge. And then the IO is actually a library for reading out data sets that are in byte format. Now, when a data set is in zip, first of all, it is being transmitted from the zip format into a byte and then from byte into a data frame. So that is how it works. So it's a kind of a three-way junction box. Let me use that word. So that is why we are in. Okay, so we run that using shift and enter. Okay, so it has actually run. Now let's call in the file paths. The file paths. Now I want to locate the file paths of the file. I go to my folder. Let me see. So as you can see, this is the data set. Now I will come up, I will come to the home tab. I will copy the path, and then I will locate my Jupyter notebook and I will click on it. Now there's something you have to know. You have to note. This this part has a kind of a forward slash, a single forward slash. Like in this place, you can notice this single forward slash also here. Now, if you run this in your Jupyter notebook, it is going to give you an error. So normally, the best thing you have to do is to type in an R here. So when you type in an R, then the path will work. Or if you don't want to type in an R, you can make the slash to be double. So instead of single, you make it double like this. So you make each of it to be double. Can you see that? So any way that you choose to do yours. So I'll just go with R, and then I'll run. Okay, so you can see that there is no error. Now, the thing I want to do is to use the zip file to unzip this particular yes, to unzip the particular file. So I'll call in the zip file function, and then so file paths, and then we want to read the zip file. Now let's see the type of the data. Shift plus enter. So you can see that it is a zip file. Now the next thing we want to do is to now read the data sets in the zip file. Now I actually created a video on how to access the different methods of accessing a zip file in Jupyter Notebook. So I'll soon be posting it on my YouTube account, on my YouTube channel, so that you can do well to see it. So let's take, for example, I want to know how many data sets I have in this particular zip folder or file. Now what you do is you say data dot name list, and then let's see. Okay, so you can see that it is only a single file that is there, and the file is called art.csv. So should in case you have more than one data set that has been compressed as one single zip, you just use the .name list to identify the one you want to choose, and then you can now work with it. So the next thing I want to do is to read it. So I'll give it a variable called art, and then I'll say data.read. Now I will copy out this art.csv. I'll paste it here. Okay, and then when I paste it, I want to see the type of data that is the art. Shift plus enter. So can you see it now that it is now in byte format? So this is when we can now make use of the bytes IO. So I'll simply come here, and then I'll say, I'll give it a new variable called let's say archive. Let me just give it a new variable called archive, and then I'll call in the function bytes IO. IO means in and out, and then I will say the art. So let's see the type of data that is archive. So can you see that now? So it is in byte data type. Now byte data type simply means data set that is in zeros and ones. Okay, so it does not is not less than 0 and is no more than 1. Now the next thing we want to do is to create a data frame. Please, the person who is can you mute yourself, please? So we're calling the read underscore CSV function. So we say pd.read underscore CSV archive. Okay, and then we run this. Let's say we need the top records of the data set. Who is this person, please? Okay, can you hear me? Okay, good. So now, as you can see, this is the top record of the data set. At least from now, we can now begin to work with the data. Initially, it was in zip format, and then we converted it to byte format, and then from byte, we now converted into a data frame. So instead of you using the regular conventional software, computer software, you can do it directly this way. Now we want to start properly. Now there's something you have to notice with this data set. This data set is actually data that was collected over time from patients, about patients. So it talks about individual patients that had, how do I put it, heart diseases. Now take for example the first record. The patient's age was 52 years of age, and then the sex. If you notice, all the data points here are all in numerical data format. So meaning that this data set, there's what we call feature engineering in data analysis. So feature engineering has actually been done on this particular data set. So in feature engineering, what it means is that, let's say if you have a male and a female as a kind of a categorical data point, you can assign a male to become 1 and then a female to be 0. Do you understand? So each of the data points is actually assigned a value so that the machine can be able to do what? To identify the patterns in those data points and then be able to draw out a conclusion. So if you see across the features, we have this age, we have the sex, we have the CP, the test BPS, the coal and all that. So all these are all features that determine whether someone has a heart disease or not. At the end of the day, you discover that if you look towards the target, this is the target, you will notice that there are zeros and then there are also ones like that. So that is for that. So now let's check for the appropriate information. Let's see what we have in this data set. So checking for appropriate info. Now you can make this particular cell to be a markdown, and how you simply do that is to click on escape and then M. Can you see that? So once you click on escape and M, then you click shift and enter. That is so let's see. The first thing is df.info. let's see the necessary info that we have concerning it. Okay, I think I need to call in the function. Okay, now, so we have, these are the columns, age down to target. Then the individual records is just 1025 records of data that we have here, and then they are non-null. Non-null means there is no empty values. Every single row has a value in it. And then the data type, it is int64. Int64 is the data format for numbers. Is the data format for numbers. And then the float 64 is also the data format for numbers, but in this case it is for decimal numbers. So the computer is able to say, okay, this particular number is a whole number, this one is a decimal number. So I think that is for the information. Then we want to see the column. So that is also good. Now the reason why we are calling out this column is so that we can use it. Okay, subsequently as we go through the teaching, you are going to see why we call out this column. Then we have we want to see the statistical property of the data set. Yes, the statistical property. Now that is what we call df.describe. We run. Okay, so this gives us the statistical property of the data set. If you can see, it is quite a long it's quite as in it takes the whole space, so you can decide to transpose it. So you click on .t. We run this again. Can you see it has been transposed? So what transpose means is that you are able to make the features that are in the rows to actually become the column, and then those that are in the column to become the row. That is what is happening here. Please, is there any question thus far?
Yes.
Okay. Okay, to copy out the file path. Okay, so you go to the folder where the file is located. Can you see that? Okay, and then you click on the home tab. You will see this place called copy path. Yes, then you click on it. The path has been copied. Do you understand it now?
Yes, I also have a question.
Okay, okay, I'm coming, but the first person that asked, do you understand? Hello?
Yes.
Okay, it's all right. So okay, so the next person.
Yeah, thanks, Sam. I've been able to finally get the Jupyter notebook.
Okay.
Please, what was the first step you took to come to this stage?
Okay, so we imported the necessary libraries, the libraries that are very important in this project.
Okay. You showed me an Anaconda 3 contact desktop. The first, after opening the Jupyter notebook, you showed me files run in clusters. I don't know the first thing you did before this kit opens up.
Files. Okay. Is it something like this?
Yes.
Okay, good. So you locate the folder you want to build your Jupyter notebook. Any folder, you can simply click on it, and then let's take for example, if you notice this is custom office templates, I click on it. Now if I want to create a new Python 3, I will simply click on this new. Can you see the new? Yes, I'll click on it. You see Python 3.
Okay, thank you.
You're welcome. So now, is there any other question?
So please, my question is, this is a prediction analysis, right?
Yes, this is a prediction analysis.
Okay, so before we do this prediction analysis, we have to clean up the data, right?
Yes.
Okay, so now we assume that the data is clean.
Yes, the data has been cleaned already.
All right, thank you.
You're welcome. So the data has been cleaned already. That is it. But normally, if it was a raw data set, it's, of course, you do data cleaning and then feature engineering before you get to this stage. Okay, so now I want us to take a look at these statistical properties. Now, if you look at this, the count of each row is 1025. If you see, the mean is 54 for age, and then for the sex is 0.69, and then if you notice, the call is what, 246. Now, if you look at the standard deviation, this is 9. Okay, so that means when we talk about standard deviation, we are looking at the square of the distance or the dispersion. How far is the nearest value from the mean of a particular feature? So in a feature like age, how far is the nearest value from the mean? So that square of it is actually the standard deviation. The distance or the level of dispersion is called the variance. Now, so that means the next value after the mean is like 9.07, as in 9.07 away from the mean. Then if you come here, you discover 131 is the mean, and then 17 point, the next value is 17.51 away from the mean, and also for the call. Now, the reason why I'm describing all this is there is a stage in data analysis called data transformation. This particular data set, we are going to be transforming it before we build the model. And that is where we are going to, that is after we are going to end at the data transformation. So tomorrow we are going to build the model properly. Now, in data transformation, there are actually 3 stages of data transformation. In short, there are 4. The first one is what we call data rescaling. Okay, let me just quickly type it here, and then I think I'll change it to Markdown. Data transformation stages. So we have 1, data rescaling, and then the second is what we call data normalization. Data standardization. And then the third one is what we call data normalization. And then the fourth is what we call data binary. So now in rescaling, we are simply looking at, I'm coming, let me. So in rescaling, we are simply looking at the minimum value and the maximum value across all the features of the data. Now, if you look at the age, the minimum value of an individual in the age is 29, and then the maximum value is what is 77. And then you look at the coal, the minimum value is 126, and then the maximum value is what, 564, which is quite high. And then talak, the minimum value is 71, and then the maximum value is 202. Now, these are just examples of or should I say the level of how wide the maximum value can be from the minimum value. And remember, if you want to present these data sets as a visualization, you will discover that features such as CP with minimum value as 0 and then maximum value as 3 will not show in the data set. I mean, will not show in the visualization. Why? Because their values are very what? Are very small, very, very small compared to talak and coal and trace BPS. So that is why we need data what rescaling. So in rescaling, we are going to tell the data, as in we are going to tell the machine that, okay, we want this data set to be in between two numbers, 0 and 1. So when you are dealing with audio data sets, let's say you want to be able to discover emotions in a particular data set. Maybe let's say a woman is crying very well and she's so emotional. You see that, and then, or maybe someone is very happy, and then the person begins to shout for joy. The voice goes very up, and then sometimes the voice comes very down. So because of that, you can choose your data. That is your during rescaling, you can decide to say, okay, I want my values or the range to fall between -1 to 1. So should in case the voice goes too high, it will not pass 1. Should in case the voice goes too down, it will not pass -1. So in this case, this is not an audio data set. So we are going to be using the range of 0s and 1. Then when we come to data standardization, now in data standardization, we are looking at standard deviation. That is the how do I put it, the level of dispersion of a data point from the mean, or how near a data point is to the mean. So if you look at this now, talak, let's use talak for instance. You see the mean is what, 149.114, and then the standard deviation is 23.02, which is quite on the high side. Now take for instance, you have 30 children in a class. Now those 30 children, their age ranges between 3 to 5 years old. So 3 to 5 years old, their mean will be what?
That's 4.
Okay.
That's if they are 3, 4, 5.
Okay, so you have 3 to 5 years old child, and then their mean is supposed to be what? Is supposed to be 5 and 4. So now if you have a child that, or let's say multiple children that their age is 5, you will discover that the level of dispersion from the mean will be skewed. That is, it will tilt, that is, the graph will tilt towards those that are having, that is, those that are of 5 years age. Do we really understand?
Yes.
Good. So in that case, the standard deviation will be very, very high. Now we come to data normalization. Now in data normalization, we are trying to say we want this data set to be normalized. We want it to be normalized. Now when a data set is normalized, is simply when the mean, the logical center point, and the 50th percentile are in the same range. Now this is the 50th percentile. This is the 50th percent. So you can see it's 50%, 56. The for trace BPS is 130, and then if you discover 130, okay, let's use the, hello, can you hear me? Okay, so let me share my screen.
Incoming call from Pizza Boy. Incoming call from Pizza Boy.
Okay, so as I was saying, now normalization. So I was saying that when you have the minimum value to be let's say for the trace BPS, the minimum value is 94, and then the maximum value is 200. Okay, let's go with, I'm coming, let me choose a better number. So let's say we have old peak. Now the minimum value is 0.0, and then the maximum value is 6.2. What do you think will be the mean? What do you think will be the mean? You have minimum value 0.0 and the maximum value 6.2.
0.06.2. You need to be 3.1.
3.1, good. Now in normalization,
so I think to get okay, maybe here because minimum and maximum, that's the range I think. So I think to get me once you have the exact value of
yes, that is it. But in this case, there's a point I'm trying to drive at. So that is the mean. Now in if for a data set to be a normalized data set, the 50th percentile must be the same as the 50th percentile must be the same as the mean. So, but now if you see the 50th percentile for this, you discover that it is what, 0.8, and then the mean is 3.1, meaning that the data set is skewed to the right. Hello? Hello, can you hear me? Hello, can you hear me? Hello, can you hear me?
Yes, you can hear me.
Okay, so as I was saying, the mean is 3.1, and then the 50th percentile is 0.8. So meaning that the data point is possibly skewed to the right. Do you understand it now? So Sonia, I'll call you back. I'll call you back, please.
Okay.
Yes, yes. Bye. Okay, can you hear me now? Okay, can you hear me now?
Yes.
Okay, so as I was saying, the data point is possibly skewed to the right. So in that particular case, the data set is not a normal data. So the logical center point
I don't understand.
is all right. Now let's use the old peak. The old peak feature. This is a column in the data set. The minimum value is the value started from 0, and then the highest is 6.2. Now between the two values, the mean is supposed to be 3.1. Now if you look at the 50th percentile here, the value of the 50th percentile is 0.8, which is not the same as 3.1, meaning that this particular column is not normal. And if you check like this, column by column or feature by feature, you discover that the 50th percentile is not the same as the mean. That means your data set is not a normal data set. And when it is normal like that, you do what we call data transformation. So the first one was rescaling, the second standardization, the third normalization, and then the fourth is binarization. You know, the thing is, binarization, you don't take it, it is not something of, 1 2 3 go. As in, that is not how do I put it, in ascending order. You can, if you look at the data sets and you discover that there is no need for rescaling, you can simply do standardization. Or if you look at the data set, you see that there is no need for rescaling and standardization, you just move ahead to normalization and you start building your model. So then binarization has to do with it involves feature engineering, where you are able to extract the feature, especially features that has to do with that has to do with category. Take for instance, sex of a child, male or female. You can see that, so zeros and ones. So that is simply binarization, to make a column or a feature to be in binary form, which is zeros and one. So now we want to move straight into the rescaling properly. So as we can see, our data sets need a very sound rescaling. Many of the data points, they don't have many of the features don't have issues, like the sex, there's no problem, the CP, but you see this threats BPS, Hall, Tolac, all this, and then the age too. it calls for.
Excuse me. Can we get the data dictionary to help us understand the column?
Okay, I'm not sure. Unless unless you go to Cargo. I think this data set I downloaded it from Cargo. If you type at CSV, I think you are going to see the dictionary.
All right, thank you.
Yeah. So we want to go straight into into rescaling. Now, remember, this is what we call data transformation. So we call in the sklearn library, sklearn.preprocessing. We import. First of all, before this, I'll create a new cell and then I'll call this data rescaling. I'll change this to a markdown and then so we import the min-max scalar function. And then after we have imported it, one thing you have to know is that the sklearn.preprocessing function actually works by it works best when the data set is converted to a list form or is converted to an array form. So you have df underscore array equals, let's see, okay, df dot values. So the dot values function converts the data points into a list form. So let's see how it looks like. df.array. We run. Okay, so we can see it has been converted to a list. Of course, you know what a list is. A list is actually covered by a square bracket. So you have the values in square brackets. Now the next thing that I want to do is to call out the min-max scalar. So we say scalar, we assign it to a variable called scalar, and then we say min-max scalar. Okay, I'm sorry, before that we have to divide the values into 2. Okay, we'll divide the values into 2. Now the first one is the input variable, which we are going to call x, and then we'll say x equals to df underscore array. We want all the rows. So anytime you want all the rows, you are going to use colon, and then we want 12 columns. Let me show you now. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Can you see that? So now, if you want all the rows, just as I said, you are going to call out everything. And then if you want all the columns, if you want just that is this age down to tal, this is the input variable. This is the input variable, age down to tal, and then the output variable That is the target. What are we trying to achieve? What is our result, or what should the machine be looking at? That is what we call the output variable, or the target. So the target will be assigned to a variable y, and then every other feature will be assigned to the variable called x. So this is it. So 0 to the 13th column, and then the y is df underscore array.
Please, I have question.
Okay.
So how do we identify which is the target variable and the one that belongs to other variables?
Okay. So now you see, this is a data set that has been collected. So take for instance, in the hospital, a patient comes to the doctor, and then the doctor asks the patient, okay, what is wrong with you? Maybe, and then the patient starts saying, I used to feel headache. Or the doctor asks, do you feel headache? Now that question demands either two answers, as that is either yes or a no. So imagine a column to be headache, yes or no, and then the patient says yes, and then the doctor asks again, do you feel dizzy? And then the patient says no. If after all these questions, and then the person went to do the test and then discovers that he or she has malaria, the malaria now, the malaria that the person has will become the target, meaning all these other questions that the doctor has been asking the person actually led to the confirmation that the person has malaria. And then maybe another patient comes, and then the doctor still asks the patient these questions, and then at the end that person is not confirmed to have malaria. So someone who has malaria will be given the target 1, and then the person who does not have will be given 0. So at the end of the day, you will now bring in this data into the machine, and then you tell your model that, please, I want you to use these input variables, these questions that were asked, to find out or to identify patterns which will make me to know that this person has malaria or not. Do you understand it now?
Yes.
Good. So that is, so at the end of the day, the target was the result. 0 means the person did not have the heart disease, and then 1 means the person has heart disease. So that is the target. So now for the target variable, we say we need all the rows, and then we need the last column, or the last feature. When we run this, let's see. Okay, so we want to see what y looks like. Let's run. Can you see that now? You can see an array. So the data type of the y is an array, and then you have 0, and then you also have 1. So that is how it looks like. Now, one thing you have to know is that when you are dealing with array, there is a library called NumPy. NumPy is a library that has to do with array, and apart from that, it is the library that has to do with numbers. From the name NumPy, it's if you want to do anything having to do with arithmetic calculations, operations like that, you want to build a robot, and all that, you have to work with NumPy. So now from NumPy, we are going to import a function called setPrintOptions. Set_print_option. Okay, so now set_print_options is just a function that gives us the results of the data points in the choosing decimal value. So let's say as we start working with this data from this point, we want it to be giving us 2 decimal value. That is what it will show us. We want it to be giving us 3 decimal value. That is what it will show, like that. So anyone that you choose to work with. So, but it is not a must. It's just that if in the process of doing this data transformation you are beginning to have data decimal values of up to 8 decimal points, that means all of them will be occupying your screen. So because of that, you have to set the print option. Now we run this. Okay, so we have set it. Now we can now say scalar is equal to the min max scalar. Okay, and then we want the feature range. We want the feature range.
Sorry, it's skipping. I don't know if other people are expressing.
Okay. Is it my screen?
Yeah, thank you.
But can you see it now? Hello?
Sorry, I can't see your screen, man.
Okay, just a second. Are you serious?
Yes.
Okay. Okay. Festus, can you see it? It's all right. So let's continue. So we want the feature range to be between 0 and 1. And then the next thing we want to do is we want to assign the this particular scalar into a variable called rescaled x. And then we say scalar, we want to fit in the data now. fit and then transform it. So fit underscore transform is actually a function to fit in the data point and transform it. Then let's set the print option. Set print option. We want the precision to be, let's say, 2 decimal place. So precision will be equal to 2. Then let's print. We'll print the rescaled X. Let's see what it will give us. Okay, feature range is not defined. Okay, let's see. Feature range will be equal to X is not defined. Oh, sorry, I'm supposed to use a capital letter X. And we run this. Set print option. Set underscore print options. Okay, so can you see that? Hello, can you hear me? Festus. Richard.
Yes, I can hear you.
Okay, good. So you can see that the decimal place is in the values are in 2 decimal place. So as it is, the data set has been rescaled. It has been rescaled. Now the next thing we want to do is to now create a new data frame using this particular data set. So we create a new data frame using the rescaled data set. So we call in, let's call this rescaled X df, rescaled X and then df is equal to pd dot data frame. So we are creating a new data frame, and then since we've gotten the data already to be rescaled X, we simply type rescaled X. We want the columns, can you see that, to be equal to, okay. Now this is where we now use the column function that I typed here. So we'll copy out this age down to tal, and then we'll drag it down, okay, and then you put it, yep. Now let's see what it will give us. Rescaled XDF. We want to see the top records. Run. Can you see that? Hello, are you there?
Yes, we can hear you.
Okay. So now, so this is the new data frame. Remember, there is still the target variable that we've not added. So the next thing we'll add the target variable. So in adding the target variable, we'll say rescaled XDF. We'll give it a new column called target, and then we assign it to Y, capital letter Y actually, because the capital letter Y was the variable that we assigned to the target column. So then we run this. Okay, so it has been added. For us to confirm, let's just see rescaled XDF dot .ed. I like using .ed to give us the top row, because if you decide to just be calling out the data frame, your screen will be full of rows of data. So you can see that the target has been added to it. So rescaling has been done completely. Then the next thing we want to do is standardization. Remember, just as I said, it is not a must for you to go through the 3 stages. So it is depending on how you look at the data set. If you notice all these errors, you can decide to go through the 3 of them. But if you notice just one, you simply do the one that you notice and you go ahead with the modeling. So from sklearn dot pre-processing, that is the function for data transformation. So we import the standard scalar. The library for pre-processing is called sklearn. The library for data transformation is called sklearn.preprocessing, and then the function is standard scalar. So we change this to an array. So we say standard underscore array. Let's give this standard x underscore array will be equal to rescaled, let's see, xdf, okay, dot values, and then we want to see what it looks like. Okay, so it has been. Now the next thing, we want to assign the variables as quickly as possible. So we are saying x is equals to standard x underscore array. We assign it just as we did. So we want all the rows, and then we want the 13 feature, and then the target variable, which is standard x array, then all the rows, and the last feature, the last column. So we run these two. Okay, so since we have done that, the next thing we want to do is to now call in the standard scalar function. So we have scalar is equals to standard scalar okay dot fit. We want to fit in the data set, and then after fitting in, the next thing we want to do is to transform it. Scalar dot transform x. Okay, now of course set print option, set underscore print option. We want it to be 2. Precision be equal to 2. Print data. X is not defined. Okay, so I'm supposed to use a capital letter X. Okay, so can you see that now? So that is, so as it is now, the data has been standardized. Before I actually got to this level, I want to show us something here so that we understand what we are talking about properly. So let's say I create a new cell here. So I want to see how skewed that this data set is. How skewed that it is. Let's use, which column will I use now? Which column? Let's use an old peak. So df dot old peak have kind equals to density. Let's see. Okay, sorry. Plots. So now, please just look at this. Look at this. Now, if you see this data set, you will discover that it is not in this point is not in the center. Is that not so?
Yes, yes.
Good. It is skewed to the left, meaning that there are a lot of numbers on this particular axis instead of it being where in the center. At least by the time we are done with the transformation, you will discover that the numbers will be normalized. It will be in the center. Or let's take for instance another column. Let's say talak. Let me see. Okay, talak. So this is something that you have to do to confirm your errors before you start the transformation process. So we want the kind to be equal to density. Let me run this. So can you see that? So this is also skewed to the right. So there is a high spread of numbers to the right, away from the middle, away from the mean and the 50th percentile. So that is what we are talking about. So by the time we are done with these transformation stages, you see a change in all these. So the next thing we want to do now is to create a new data frame using the standardized data sets. Okay, so we call this let's say standard underscore df equals to pd dot data frame. Okay, and then we need the data that we are using is data, and then the columns equals, so simply copy out these columns that was here. Let's see. Then we paste it here. Okay, then we need to add up the targets variable to add the target variable to the data frame. So we'll say standard df, we'll assign it a new feature, which is target equal to y. Run this. Okay, so we want to check it out. Let's see standard df dot head. Okay, so this data set has been standardized. Now the next thing we want to do is normalization, which is the last normalization. We change this to a markdown, shift plus enter. Now from sklearn
Incoming call from Pizza Boy.
dot pre-processing,
Incoming.
we import normalizer. Okay, shift plus enter, and then the next thing is we'll now change this to an array. So let's say normal array, let's just give it a name, normal array or normal r equal to standard df, which was the new name, new data frame that we gave it a year. So standard df dot values. Okay, run this, and then the next thing we want to do is to assign it to we'll divide it into input and output variable. Now x equals to normal r, and then we want all the rows, and then the 13th column, and then we want the y equals to normal r. We want all the rows and the last column. Run this. Right now we can now call in the normalizer. So in calling out the normalizer, we are going to say, let's give it okay, let's say normalizer equals to normalizer okay dot fit. We are fitting in the data, we are fitting in x. After fitting it in, the next thing is to transform it. So normalize x is equal to normalizer dot transform, and then you are transforming what? X. So I want to talk on this now. If you discover this is in two, let's say 2 lines, but you can decide and say, okay, you don't want 2 lines, you want this particular dot transform, you can fix in this dot transform here. Can you see that it will still give you the same result? So just take it that this, you have normalizer with a small letter n equals normalizer, which is the function, and then we are fitting in the data. We are using this function to fit in the data set. Now what it gives us here is what we will now use to do or to transform the data. So that is what the second line is trying to say. So instead of you writing 2 lines of code like this, okay, you can simply use this, you can simply put in this dot transform this place, and it will still give you the same result. In short, let's use it so that you see what it is. We run. Can you see that? So you can decide to run it in 1 line, you can decide to use it in 2 lines. So now we want to set our print option, set underscore print options precision equals 2, and then one normalizer. Okay, so you can see it is in 2 decimal. So the next thing we want to do is to now create the data frame. With the normalized data set. So in creating it, we'll call this normal. I don't want to use a capital letter. So normalized df equals pd dot data frame, okay, underscore normalizer Okay, and then we want the columns to be equal to, okay, so we'll come here again, we'll pick the column. Okay, and then we'll add up the target variable. So we'll say normalized underscore df. We want the target variable to be target equals y. So we want to see what it looks like. Normalized underscore df dot head. This is a call out function. Okay, so now the data set has been normalized. Yeah, so we are now done with the data transformation stage. So the data set has been transformed. It is ready for modeling now. So these are what, so let's confirm. Let's take this, we'll copy it, and then let's see what it is like now. So paste it here. We'll change this df now to normalized df. Can you see it? Now look at this now. So it is now, look at the difference. Let's see the previous one. Now the range of the value has been what? Has been widened. Initially it was skewed like this. It has now been widened to accommodate more values. Did anybody notice any difference?
Yes.
Okay.
Yes.
So let's check this other one. Let's check this other one. Old peak. Copy. So we say normalize df, I think. Okay. Okay, now let's look at the previous one. Can you see that now? So this it was still what it was, as in the data point was adjusted to accommodate more data. You can see that this one was a bit tiny, and then this one has been widened. You see, this is the significant changes that data transformation can bring about in a data set. You discover that if you are to build a model with the original data set, your level of accuracy will not be up to that when you work with a transformed data set. At least these changes that you can see here, they can actually increase your accuracy when building a model. You can see that. So this one is tiny and all that. Do you understand what I'm saying, guys?
Yes.
Yes.
Oh, okay, it's all right. So someone is raising his hand. Who is that person, please?
Yes.
Okay.
Sorry, it was a mistake. It was
Okay, it's all right. So is there any question? Okay, so okay, Daniel.
Really want to thank you for this time, for taking part and to explain all these things. So I wish we can have a kind of fast recap tomorrow before you delve into the next thing you want to discuss tomorrow. I don't know.
Okay,
It's gonna be very good.
it's all right. It's all right. There's no problem at all.
And again, if you can actually send us this Python file
Okay,
so that we can place for
it's all right.
practice.
I'll.
Because we are concentrating on one part.
It's all right. I'm going to send it to the WhatsApp group. So I'm going to send it to the WhatsApp group, and also I'll send it to my GitHub page. Okay. So, is there any other question?
Please, I'd like to find out if I can get the video.
Yeah, I tried to record it using another computer software because it appears Google Meet they are making a very significant change to their policy. So I'm doing my best in that regard. That is what I will say.
Okay. Thank you for the time, and thank you for sharing your knowledge with us.
Thank you, thank you, thank you, thank you. So guys, this is where we are going to end it for today. So when we come tomorrow, we'll go into the modeling properly.
Thank you so much, Sam. We appreciate it.
Thank you, thank you, thank you. So see you tomorrow
Thank you.
then.
Okay.
Yes, yes. Bye.
Hello, sir. I
Yes,
have a
yes.
question.
Okay.
I don't know if you have the documentation for this data statistics analysis, but after this, I could not really get what you were trying to explain. Between the most mean and when this median and the rest of the show are like, so I need the documentation to follow up with what you were trying to explain.
Okay, okay. I think there are a lot of documentations on the internet. For my own self, unless I will check, but I don't really have on my part.
Okay, all right, thank you.
Yes, yes. But if you want me to still buttress on it, I can at least. Maybe I'll just use 1 minute.
Yeah, I think that will be fine. That will be fine.
Okay. So when I was describing the data transformation stages, I said that there are 3 stages. One is rescaling, second standardization, third normalization, and then the binarization. Now the rescaling has to do with scaling up the data points such that the individual data are not too far away from each other. Now if you look at this if you look at these particular features, across these features, you will discover that the minimum value here is 29, the maximum value here is 77. Now the maximum value here is 200, the minimum is what, 94. Now if you look at this is quite wide apart. Okay, apart from being wide apart, if you have to visualize this particular data set, you will see this column on the chart, and meanwhile CP column, which is having the maximum value to be 3, will not be seen. So just compare a column that is 3 and then that of 564. Can you see that? So all this dispersion, all this that is, how do I put it now, the longitude in the to undergo causes the data to undergo transformation, as in rescaling. Is that clear? Do you understand?
Yeah, I do.
Okay, so then the standardization has to do with the standard deviation. So standard deviation means the level of dispersion. So from the level of that is the level of dispersion of a data point from the mean. So you have a particular data, as in you have a particular you have a feature such as the sex. Now it has a standard deviation of 0.46. Okay, that may not be a good example. Let's see call. Call has a mean of 246.0, and then the next number or the next data point from this mean is 51.59 distance apart from the mean. Do you understand it now? Do you understand it now?
Yeah, that's
Good.
far apart, right?
Yes, that is far apart. That is what far apart, because it can actually cause a shift in the visualization. If we are to visualize this code now, you will discover that the data is shifted, is tilted towards a particular side, either to the right or to the left. Now, so that is why we need standardization. So standardization helps us to bring the standard deviation at least to the barest minimum. Highest should be 1. The standard deviation should not cross 1. But you can see here is 51 point. Okay, so it's quite very far. Then the normalization has to do with making the data set to become normal. And when the data set is said to be normal is when the mean, the 50th percentile, okay, and then there is what we call the logical center point. So you have a range of data such as let's see, this is 0 and then this is what, 1. So the between 0 to 1, what do you think should be the value in the center?
0.5.
0.5. Good. So 0.5 is supposed to be the value in the center, but then you discover that the mean is what, 0.69, which is not 0.5, and then also the 50th percentile is what, is 1, which is not 0.5. So that means that the data set is not a normal data set. Do you understand it?
Yes.
Yes. So in that case, you now do what we call normalization. And then binarization has to do with making each feature to be zeros and one depending on what you want to achieve. So most times it is being done on the target column. Okay, where you have zeros and then you have ones, like that. Have I been able to answer your question?
Yeah, thank you.
It's
Yeah.
all right. It's all right. So thank you so much, guys. I think I've spent quite a good time here. So I'll see you tomorrow.
Yeah, thank you, Sam.
Thank you. Thank you.
Well,
Yeah.
thank you very much.
Thank you. Thank you. Bye.
Bye.
Hey, Jesus.
Yeah, it looks like